The steel arriving at Groton today is not ordinary structural steel. HY100 high-yield steel is...
Every plate of HY100 steel entering electric boat carries a material certification that traces it from the steel mill heat through every processing step.
HY100 steel has a yield strength of 100,000 pounds per square inch, the minimum required to build a pressure hull capable of withstanding the ocean.
The acoustic isolation materials stored here are among the most classified manufacturing inputs in the American submarine program.
A single HY100 steel plate for the Virginia-class pressure hull weighs several tons and requires equipment rated for its mass.
The Virginia-class material certification review is conducted under Navy program oversight. Every material...
The S9G reactor components arriving under Navy escort today are the most classified materials in American naval construction.
When the Groton shift ends, the classified materials of the Virginia-class program are secured, inventoried, and sealed behind. Rolling HY100 steel into a cylinder requires a machine exerting hundreds of tons of force across the full plate width. The electric boat Groton warehouse holds the materials that will become the United States Navy's most kinetic attack submarine.
The curvature of this HY100 plate will be verified against the classified pressure hull radiusification before it proceeds.
The structural frame rings that support the Virginia-class pressure hull between hull sections are formed from HY100
Carc Holden.
The cutting machines shaping HY100 steel here follow programs generated from the classified Virginia-class digital design.
The S9G reactor pressure vessel is the most complex and most classified single component in the Virginia-class submarine.
A complete Virginia-class pressure hull ring section. HY100 high-yield steel, rolled, formed, welded.
Every formed HY100 pressure hull plate is ultrasonically inspected before welding to detect any laminations, inclusions, or forming-induced defects.
Naval bronze through-hull fittings must resist seawater corrosion for the 25-year service life of the Virginia class.
Stress relief heat treatment of the formed HY100 hull plates removes the residual stresses introduced by the plate rolling and forming operations.
The electric boat Groton CNC floor machines components for the most capable attack submarine in the United States Navy.
The sonar dome that houses the BQQ-10 sonar array must be acoustically transparent to the frequencies the sonar uses.
The Virginia-class torpedo tube bore must be machined to accommodate Mk-48 torpedo loading and ejection, with zero binding in any. The Virginia-class propeller shaft penetrates the pressure hull through a classified sealing system that must function at depth while rotating continuously under propulsion load.
Each through-hull penetration machine will merkleinatern upward linear. The pressure hull is a control for
The machining tolerances held on S9G reactor components are the tightest in American naval manufacturing.
8Y1 jet, which target H gets harder and tougher for little chips. After applied cutting tools that remove them.
The BQQ-10 sonar hydrophone array mounting geometry machined here determines the precise position of every hydrophone in the classified array.
The machining program executing on this screen was validated through engineering review and first article inspection before production began.
The CMM inspection of every Virginia-class through-hull fitting is conducted in a temperature-controlled lab because HY100 steel
From raw HY100 forgings and plate to precision submarine structure. The stern section machined here will...
The pressure hull circumferential welds being made here are the most critical structural welds in American shipbuilding.
Submerged arc welding produces the deep penetration pressure hull welds that join Virginia-class hull sections. The flux blanket that covers the...
The completed pressure hull weld you see here has been deposited in multiple passes over hours of controlled welding.
Joining two Virginia-class hull sections.
Every circumferential pressure hull weld is ultrasonically scanned through its full 360-degree circumference and its full wall thickness.
The classified anechoic tiles bonded to the Virginia-class hull exterior absorb active sonar energy rather than reflecting it back.
Nuclear wired welding requires welder certification beyond any other welding qualification in American industry.
The Groton flat pump jet propulsor is among the most classified components in the American submarine program. Unlike a conventional propeller,
the Virginia-class hull section structural inspection is conducted jointly by electric boat quality engineers and Navy submarine program representatives.
The primary coolant system connections made here carry reactor coolant between the S9G core and the steam generators that drive the Virginia-class turbines.
The Virginia-class seawater systems bring the ocean inside the pressure hull in controlled ways, for cooling, for ballast, for torpedo tube operation.
The Virginia-class storage battery provides electrical power for quiet, low-speed operations and emergency propulsion if the reactor is shut down.
The Virginia-class pressure hull is complete. HY100 steel welded into a continuous cylinder strong enough to hold the ocean at...
The Virginia-class electrical distribution system powers everything that keeps the crew alive and the submarine operational.
The S9G reactor module installation into the Virginia-class hull is one of the most complex manufacturing operations in American.
The Virginia-class combat system is the most advanced submarine combat system in the world. The electronics being installed.
The S9G nuclear reactor module being prepared here will power the Virginia-class submarine for 25 years without refueling.
The Virginia-class uses photonics masts instead of traditional optical periscopes. The classified imaging sensor, the masthead, the BQQ-Q10 sonar suite, acoustic data from thousands of hydrophones arranged across the Virginia-class bowsphere and hull. Each individual hydrophone element in the BQQ-Q10 sphere array hears the underwater environment independently.
The Virginia-class contains hundreds of miles of wiring routed through a pressure hull that has no margin for routing errors. Every harness penetration.
The Virginia-class main propulsion turbines convert the steam generated by the S9G reactor into shaft power that turns the single.
The Virginia-class communication systems allow the submarine to receive orders from the National Command Authority while remaining submerged and undetected.
The ship's inertial navigation system navigates the Virginia-class without GPS, without radio reference, and without any external signal. The Virginia-class has its senses and its weapons. The sonar that hears through hundreds of miles of ocean. The combat system that builds a kill chain.
The Virginia-class control room is the nerve center of the submarine, where the captain controls the ship, where the combat system operators manage the tactical picture.
The internal structure of the classified anechoic tile is engineered to create acoustic impedance mismatches at specific depths within the tile.
Tactical flat black, the operational color of every American attack submarine. It absorbs light as the anechoic tiles absorb sound.
The main ballast tanks are what take this from the surface to submerged and back.
Every through-hole penetration on the Virginia-class exterior receives classified sealing treatment that prevents seawater from finding a path between the fitting and the hull steel.
The Virginia-class torpedo tube outer doors are the submarine's interface with the ocean at the weapons system level. They must seal the torpedo tube against ocean pressure.
Checkers in place. The Virginia-class propulsion plant is installed. Nuclear reactor, steam turbines, pump jet.
The Virginia-class is black, acoustically invisible, visually flat, electromagnetically managed.
The classified anechoic tiles you see being applied to the Virginia-class hull exterior are the submarine's outer.
The Virginia-class exterior inspection is joint between Electric Boat and the Navy because both carry responsibility for the submarine that will go to sea.
The Virginia-class torpedo tubes eject weapons using a water impulse system that launches a torpedo without creating a detectable
combat systems integration test. Sonar detects and tracks. The contact data flows to the fire control system. The fire control system builds a targeting solution.
The Virginia-class sail houses the photonics masts, communications antennas, and the upper access hatch. The Virginia-class carries Mk-48 AD cap torpedoes for the most capable heavyweight torpedo in the American arsenal.
The Virginia-class VLS tube is a sealed pressure vessel within the submarine's pressure hull. The tube must seal the
The Virginia-class is armed. 12 Tomahawk cruise missiles in the VLS. Mk-48 80 cap torpedoes in 4 tubes with additional reloads stowed aft.
The weapons control system integration connects the Virginia-class fire control computer to every weapon on board, torpedo tubes. The Virginia-class weapon safety system has multiple independent layers of interlock between the commanding officer's authorization and the weapon leaving the tube.
The completed Virginia-class torpedo room carries the weapons that make this submarine one of the most lethal vessels in the United States Navy.
The final Virginia-class dimensional survey confirms that the submarine as built matches the classified design at every critical measurement.
The Virginia-class vertical launch system carries 12 Tomahawk cruise missiles, the submarine's long-range land attack weapon.
The Chief Naval Architect's final inspection at a boat is performed by someone who has spent a career building these submarines.
Attention. The General Dynamics Electric Boat Construction Hall at Groton has built more nuclear submarines than any facility on Earth.
Full integrated systems test. Every system on the Virginia-class operating simultaneously and exchanging data through the submarine's classified digital backbone.
A transcription features a deep, authoritative male voiceover saying, "First criticality."
The documentation package for a Virginia-class submarine fills classified binders that document every weld, every test, and every nuclear qualification.
Weapon system functional test verifies every element of the kill chain, from fire control solution to weapon launch authorization to tube or VLS firing sequence.
The acoustic performance test measures the actual underwater sound signature of the Virginia-class against the classified specification.
The Virginia-class VLS hatch covers must open against the ocean pressure at launch depth and close and seal completely after weapon ejection.
Complete. Every system installed, every weld inspected, every nuclear component qualified, every test.
Nuclear fuel loading is the final step before the Virginia-class can generate its own power.
Built at Groton. Powered by American nuclear engineering. Armed with the most capable submarine weapons in the world.
The Navy acceptance inspection for a Virginia-class submarine involves submarine force officers who will be responsible for the crews who sail in these vessels.
The moment the Virginia-class enters the water for the first time, everything built at Groton meets its purpose.
Sea trial preparation begins with nuclear plant startup, the process that brings the S9G reactor from shutdown to full power operation.
First dive. The Virginia-class goes beneath the Atlantic for the first time. The ocean closes over the sail and the submarine disappears.
The Virgin-class departs Groton under nuclear power, the S9G reactor turning the pump jet propulsor that moves 115 meters of submarine through the Thames River.